Hello, welcome back to our stream. Today is 3rd of April, and today is gonna be quite exciting because we're gonna try to get the real action going on here with our DQN model. So I've been training the DQN model, like trying it out for the past few minutes since yesterday. So all these numbers, some of them are making sense, some of them are not. So I think especially the loss is not making sense. So that's way too high. And probably the reward as well, because we're calculating the reward of the current board, right? It's calculating the reward of the state, not the action. So I think if I want to model the reward better, we probably need to take the delta instead of the current reward for the current board, right? So that's something. And also the state, I'm not sure if I'm encoding the state correctly. So I haven't checked that as well. So today we're gonna take a look at a few things. I think we're gonna take a look at logging, which I had already done it. So what's left is we're gonna take a look at the state, the reward, and action on these three components of the DQN model. See if they are working as intended, or do we need to tweak them? I think definitely I need to tweak the reward to make this loss less scary. So now it looks very scary. All right, let's stop this training. It's not, I don't think it's doing much as of now. So I'm gonna increment the counter of our run number. I'm gonna do something a little bit more intelligent. So I think, so one thing we could do is when we get the state tensor, I think somewhere here, we get the state tensor, this one. Okay, so this is the get without learn, and the other one is get with learn. So here I think we need to actually debug it. We actually need to debug whether it's working correctly, right? Do we have a debug flag somewhere? Oh, we have this. Do I want to import it? Okay, let's just import it. Var agent log equals to okay, it's not auto completing for me, so oh sorry, it should be agent string. Sorry, so var agent string, and if debug, then we're gonna do this. I'm gonna output the agent state here. Agent stream equal to log agent. Okay, right? Then I'm gonna write the thing here. All right, so we're gonna write this. I think before that, I'm gonna write something like get state to tensor. Yeah, that looks correct. Let's add a dash n just in case. I'm gonna wrap it with if debug. Okay, so this is this one, and we're gonna also log this one. Okay, okay. So you're gonna do this, and we will see if we're getting the correct states. I think this is gonna generate a lot of random stuff, but hopefully it's not too much. Cannot read property undefined. Okay, so we can't actually do that, right? Where's the debug thing? Okay, maybe I'm just importing it at the wrong place. It's finished training. But I don't see the log. Oh, because okay. Because the debug is false. Oh my god. Okay. Okay, we're gonna turn on the debugging. Okay. Okay. So it's printing out something. Let's take a look at this. Okay, this is 1, 2, 3, 4, 5. So this is each cell. Hold on a second. So this is. Let me interpret this. It's in the middle. It's 5. Okay. Okay. I kind of have to spend some time interpreting this tensor output. So this is the value. And this is the position. So this is 1, 2, 3, 4, 5. And the tensor, I guess, correspond to that. Just all zeros, right? It's not very okay. There's a 1 somewhere. So it's kind of the shape is kind of different from what I expected. So let's do a two array sync. Let's do an array sync instead, so that I can understand what's actually happening. Buffer of a specific dimension. Okay. I think this would help us understand what's happening, hopefully. So I think on the first turn we should have shipyards and ship count. Ship count should be 500. Okay. So Okay, there's way too many decimals here. Can I convert a buffer to array? I can't, right? Let's do a JSON stringify first here. No, so we'll do a JSON stringify here so that we can print the whole thing. And we're also gonna trim the core here, right? So we're gonna trim the core here. So we don't want this. How can we convert a float to an integer in Node.js? Okay, I can just Google it, I guess. JS float to int. I guess math.round would be fine. Okay, so this should help us reduce the noise. Let's run the training again. My reward now is null. Okay, my computer is actually hanging. That's not a very good sign. Reward is null. Why is the reward null? Okay, that is not very good. Maybe I shouldn't have done that. Now let's think of a clever way to do to print this stuff. Okay, let's introduce another variable. Let printed equal to false. Printed states. And not printed state, right? Printed state equal to true. So we only print this once. We only print this once. I think we don't try to do funny formatting here because it's just gonna screw up the whole thing. What is now? This is the first state. 31 times 31. Okay, so it's 31 times 31, which is correct. Okay, so I guess now I understand the shape. Let's see if we can find 500 here. We didn't find 500 here. We didn't find 500 here. So that doesn't look correct. We should have a 500 shipyard at the beginning of the first turn. Yeah, we should definitely have the shipyard at the beginning. And it's not recording it, right? There's a 1 here. Okay, let's take a close look at how we encoded this to begin with. The player shipyard, opponent shipyard count. Okay. Index 3 should have the ship count, but it didn't have the ship count. It had the number 1. Find a 0, 1, 0. It's not here. 0, 0, 1 is here. So I think there's something wrong here. I'm not too sure why it's wrong. Let's print this information as well. Not too sure why it didn't get the ship count. Maybe something's wrong here. Ship count equal to 1. Okay, maybe that explains why it's like that. Oh. Oh. Oh, I think I know why. Actually, one is correct. Actually, one is correct, right? Because in the beginning you don't have, but you have core, right? So I guess that's another thing we need to encode. I forgot. So in the beginning you don't have ships in the shipyard. You only have core. Yeah, that's correct. So you only have core. Okay, so oh, okay. But the core count is not on the board, right? So we have to kind of encode it separately. Okay, so that's gonna be tricky. How do we encode this information? Okay, so we need to go back and reconsider how we can encode this core count of each player onto the matrix. So our current matrix looks like this. Height and width. Let's make it a simpler. Let's just make the core associated with each shipyard. I think that's a simple way to encode this information. I think, yeah. Each shipyard has the same core. Okay, we need to make a note here. So that will be 5, that will be 6. Max vector length is 7. Okay. So if it's current player, sure, we don't have to set the other things, right? I think we don't have to set the other things. Just gonna default to 0. Let's check. Okay, default to 0. Okay, that's good. We don't have to set the opponent stuff. So addition to this, we're gonna set the core count. I guess Copilot doesn't understand how to do this. Okay, this is the fleet. We don't want to change this. We need to change the shipyard here. Okay. Okay, so it's trying to guess what we want to do, but it guessed wrongly, which is fine actually. Shipyard.player.core. So this is what we want. And we also want to run it, correct? Opponent shipyard code. So I think this should encode the information, like the complete information of the board. Let's try to train, see what happens. I think we don't need this anymore. Right. So now we should have some 500. Okay, so it's 490, which is correct. I think this starts on the first turn. Okay, looks correct to me. Get states as tensor. So we should be able to see some stuff here. I guess we do need a convolution layer, so we'll think about that. We'll think about that maybe tomorrow. I don't want to deal with this convolution layer yet. I think we need to deal with that eventually, but I think for now we're not gonna delve into those things yet. Let's find somewhere that it doesn't have a zero. I'm having a hard time reading on this. Why is everything just zero? It's not supposed to be all zero. Like, maybe it's just I'm not looking hard enough. We can just search for like one ending with one. Oh, it doesn't exist. Wait a second. Okay. Oh, I guess it makes sense because we consume 10 cores. So wait, only the first 10 information is correct. Why is it only the first 10 information is correct? The other turns information is just zeros. Oh, I know. Because I haven't changed it. Oh my god, that's so stupid. I haven't changed it yet. Okay. My bad, completely bad, my bad. Okay, so let's remove all this. I'm gonna add this to here. Airship content. Okay, so I always forget that we need to change both. I'm not sure if there's a better way to manage this, but I've been copy pasting this for a while. So I think now it should be correct. Now it should be correct. Okay. And now we should have some non-zero values here. I can search for 490, so we still have 490. Below here, we should have some non-zero value as well. Okay, now we have some non-zero value already. Good stuff. Okay. Very good. So we also should have 0, but our own position is not 0, right? Do we not have that? No, we don't have it. Okay, something is wrong here. So this one is working, but this one is not working. Leadership 4 is the second last. column. Okay, let's search for 490 first. Oh, 490 only occurs on the last one, not the second last one. So that's definitely something wrong going on here. General property, right? Okay, I see. I see, because it exploded on the first round due to an error. Okay. Canary property right of undefined. Debug is true, right? So I guess it's another circular dependency. I think it's probably another circular dependency causing this problem. Let's just remove the circular dependency and see what happens. Okay, now we're having some correct data, I think. Let's take a look at this. 490. Oh, we don't have 490 anymore. Oh, we have 500, which is, I guess, also correct. Oh, we didn't. I think we exited too early. We didn't get the other data. Wait, that's a bit weird. We should have gotten it. Right, why are there only 2 lines here? Huh. Something is wrong here. It's not printing it. Let me temporarily get rid of this and see what happens. There's nothing here. It's definitely training, but it's not outputting here. Wonder what I changed to cause it to not work. Not train. It's not going here at all. Because multiple people are trying to write to the same file. That's why it doesn't. Let's try this. Maybe it's a concurrency problem again. That people are trying to write to the same file. Yeah, I can see now. There's already two agents. Oh yeah. Okay, I see. One is from the training, one is from the one that's running. That makes sense. Okay, I understand. Okay, so let's take a look at this. We should have 500 here. Okay, maybe let's not look at that. Let's look at some of these. Okay, so this looks correct. How about this? Okay, we do have some stuff happening here as well. Okay, that means it's correct, right? I think that's correct. So I'm pretty confident that this is working correctly now. The state is working correctly. Yeah, we can turn this off for now. And we can turn this off. So the state is now working correctly. Let's check the reward, right? So we fixed the state. Let's take a look at the reward. The reward previously we were using the raw reward from the board, right? I don't think that is a particularly good reward. So what we should be using is the reward delta, right? So if we start with 0 and we don't add the 0, okay, so that means we could theoretically calculate the reward delta. Delta equals to minus previous reward. This one is like this. Previous reward equals to reward. So now this should help us make the loss function less scary. It should be less scary now. Actually, let me rename this file to training costs. I think that's better. The loss is still very, very high. Oh, it's less high than previously. Well, why it looks like it's sometimes working, sometimes not. Can you get 3,000 cores in one turn? It doesn't seem correct to me. Let's maybe print the statistics here. Oh, this is printing the reward, not the reward delta. Okay, that's why. Reward can be reward delta equal to reward delta over reward. Or maybe let's do it separately. Reward delta okay, so now we should get the correct reward. The loss is already looking much lower than it used to be, but it's still quite high. It's at least it's not on the millions. It's in the 100,000 range, which is still quite insane, but it's less insane than previously. Okay, so it's getting some delta. So I get some negative delta, which is good. Okay, let's print it more friendly, and then we're gonna increment the training counter to train it properly. How do we convert it again from mass dot to run? Okay. Let's run the reward. It looks to be correct for the negative numbers. Right, so I think this is the run. Hopefully this is gonna give us the correct stuff. So I'm expecting low loss on the scale, at least less than 100 loss would be good to have. Then we can take a look at other stuff. So delta looks correct. And because we have a 0.9 reward discount, so it's gonna work eventually. Eventually it's gonna work. Right? As long as not all the delta is 0, it's gonna work. So our loss is 220,000. Our Q is increasing quite fast, which is good. Oh no, now the Q start dropping. The Q is dropping. Could be just a normal behavior of the model. I'm not too sure. At least the loss is dropping as well. So let's see if we can reduce the loss to less than 100. Okay, the Q is continued to drop. It's not uncommon to have Q dropping in the beginning, but it should eventually go up again. Okay, so now both Q and loss is increasing. But that's the last turn. So the last turn delta 0 is okay because the model handles the last turn in a different way. It doesn't add the discount factor or something like that. So that's actually okay. And now our loss is going up again. Action 0. Oh, the other thing we haven't fixed the action 3. We haven't fixed the action 3 yet. So we need to fix that. Action 3 build shipyard, it doesn't always build because it can have a chance to not build, and then it just doesn't capture the action and give the negative reward, so it's not doing anything yet. So now everything looks normal. The Q is increasing, the loss is dropping, everything looks fine. So we're training on like every 300, 400 steps, right? Depending on how long each game lasts. So that's too slow. I think we should be training more aggressively. I think it's just because of how this thing is set up that we can't actually train more frequently. I mean, we could sample more and train more. That's an option to mimic the correct behavior. But let's see how this works in like 100 episodes. I guess it's really hard to find an action that gives delta positive, right? It's kind of hard to find an action that gives positive delta. It's gonna take a while to figure out how to get it. Let me take a look at what is action. Action 0 is do nothing, 1 is mine, 2 is build ship, 3 is build shipyard. So we only have this 4 actions for now, and one of them is broken. So effectively we have 2 actions. Yeah, quite interesting. Quite interesting. The loss is starting to like flatline a little bit. Hopefully it can drop below 20,000 soon. Okay, drop below 20,000. Okay, that's fine. I'll take that. The Q seems to be flatline though. I'm not expecting the Q to be flatlining right now. It should keep increasing. Now we have filled up our replay memory, so now the training should become progressively better, ideally. Okay, it's looking better now. You can see our Q is increasing nicely, from 100 to 118. Loss is from 197 to 166. So it's kind of working, even though we only have 2 actions. So I think it's already working. Like DQN is working, right? So the loss is still very, very, very high. It's way too high. But it's I think it's working correctly. It's just the parameters are not that good. That's why it's. We should clip this lost for sure. We need to clip all this negative delta. Otherwise, it's too much noise. Right? Yeah. So I think the next step is we take a look at the action, fix the build shipyard action, and then we do the reward loss clipping thing. And let's watch a few more rounds, episodes of this. So loss stopped dropping and Q is still increasing. It could be just a temporary thing, so nothing to be alarmed yet. How's our memory consumption going? Okay, about 3 gigabytes, so it should be fine. So loss started increasing already, so that's not a very good sign, right? So the loss is just continuously increasing, or rather it's staying around 190k. It's staying in the 190k range. Definitely we need to do something about this. Q is still increasing, which is good. Alright, I think we'll watch enough of this round. I think it's pretty good already. I mean, a lot of things are already working. So let's try to fix that thing that we have just now. So the first thing that I'm gonna do is completely get rid of the old strategy and write new strategies that are naive, because the previous strategies are too smart and it's trying to not do things where, like, you know, if it cannot be done, then it's not gonna execute the strategy. So, but that's very bad for training because we don't know, we cannot learn from the mistakes. So we need to make a separate strategy for this model, right? So let's call it strategy naive, right? We need to make our strategy naive so that, you know, we can at least the agent can execute them, like, and learn from them. Otherwise, they're not gonna learn from the strategies that don't work, right? So that's the key idea here. We're gonna import, instead of from strategy, we're gonna import from strategy naive. And in strategy naive, we're gonna, you know, make a few changes. I'm not gonna deal with all other things. Let's consider build shipyard, right? The build shipyard previously need to consider a lot of things before it can build, but now I'm gonna get rid of all of them, right? Because the machine learning algorithm is supposed to figure this out. I'm not supposed to code logic here. Otherwise, it's just gonna cause the model to not learn how to build, right? So that's the key thing here. So I'm just gonna remove all of this logic, right? And remove this logic that prevents it from building so that it can always build, right? And then I'm just gonna remove all this logic as well, right? And remove this to if else as well. Remove this as well. Remove this. Okay, let's move this out and remove this completely. And okay, if it doesn't have path to build, we just get a safe last result, I guess. Yeah, we just get a safe last result. And that would be a simpler way to do this. For the shipyard, safe limit is for the size 0.5 maybe. And then we're just gonna add const spawn path equal to plus resource. I build a generic function. Okay, so now it should return a string. Okay. Let's resolve plus C, right? And we're not gonna. Okay, so I guess this is the correct one. And then I'm gonna move this down. If no pass, then we're gonna force the pass here. We're gonna don't care about the number of spawn. We're just gonna, you know, execute it without caring about anything, so that the machine learning can learn that this doesn't work. I think that's the better way to handle this. And build ship, I think similarly. So can spawn, can spawn. Oh, I think we can just move this out like that. Yeah, we can just do like that. This is a naive strategy anyway. And for the mine, it's the same. We don't need this at all. Mine loop. How do we deal with this case? I guess we just don't do anything, right? Just don't do anything. It's fine. Okay, I cannot learn that. I cannot do it, right? So this is a little bit tricky. I guess we have to do something here. Gonna get the last resort as well. Just gonna launch the last resort. Shipyard ship count. Okay. Okay, so I think that's correct. So I made our strategy completely naive so that it should execute all the random strategies and learn from them. Let's see. Hmm, doesn't work. Must be positive number of ships. Oh, it must be greater than 0. Okay. So actually the game is not allowing to do that. But you know, we could just make it send one ship, I guess. Right, so here we can send one ship. Build shipyard. Spawn ship can spawn. If cannot do, then it's one. Can spawn equals can spawn or one. This one spawn size is correct. Spawn size is correct. So let's see. Okay, so now the loss is much lower. We haven't done the loss clipping. Right now it's on the range of 10,000. I want to see action 3. It's not coming up yet. We don't have action 3. Let's take a look. I think we should have some action 3 at least. We can take a look at some of these. Build ship as many. Something is wrong here. So when we got the build shipyard, it's still not building shipyard. Oh wait, this is not even used. Oh no, it's wrong. It was wrong all the time. This build shipyard actually. Okay, so now it should be fixed. Okay, I didn't realize that it was wrong all the time. Now it should be fixed. Okay, let's see. Be a non-active integer. It's doing correctly, right? Wait, what is wrong here? Mm-hmm. Let's take a look at this. Okay, so this one has a problem at 105. Hmm. Yeah, no, negative number plus string number of ships. String type plus string flight plan. Okay, seems to be what I wanted. This is what I want. Let's try to run it again. Okay, let's take a look at the replay. -1, spawn -1. Okay, I think I know why. I think I know why. So can spawn, okay. Can spawn is greater or equal to 0? Question mark. Can spawn 0. Right. I think they should fix the problem. Let's start with a new run. Because the calculator can spawn this -1 and try to spawn -1. Yeah, that happens sometimes. Okay, now we're getting 3, right? That's pretty good. It's very good. Now you should learn very fast that it doesn't work. You can see how it's trying 3 and its delta is -1 is 6. Okay, okay, cool, cool, cool. Now it's actually trying to learn. Nice, nice. This is what we wanted, right? It's gonna learn that 3 doesn't work at all if you don't have the number of ships. So funny. Nice. We have 0, 1, 2, 3 all in the same round, which is nice. Now it should actually try to reduce loss by now. Let's see if let's watch a few more episodes to observe if the loss and Q is behaving as we expected it to be. So the Q should be increasing and the loss should be dropping. So that's what we're looking out for. Maybe I'll take a break and let's just watch this. Right, I'm back and let's see the loss is reducing, okay? It is reducing and Q is increasing, which is correct. We're already lower than 10K. It's pretty good. It's pretty good. Uh, so Q130 is what it means in this context is that on average, an action is gonna yield a reward of 130 in the event horizon that is discounted by 0.9 factor, if that makes sense. So as Q goes up, it's more and more, better at producing moves that are of higher value in a time horizon of 0.9 discount factor. So 0.9 discount factor is about 20 turns, I think. Can't remember. Yeah. I think there was a very good explanation on the discount factor of DQN. So I can't find it anymore. Discount factor is gamma, right? Not this one. I think there was a Stack Overflow answer. I think it's this one. Oh yeah, this one, right? So it means that at 6 turns, the reward in 6 step at 0.9, the reward in 6 steps have half as important as the immediate reward. But for gamma 99, the same is valid for 60 steps. So actually, we should use higher gamma for this case because one game is 400 turns. We need to at least consider like maybe 100 turns later. Right? So we actually need to increase gamma in our case. As you can see, our loss is not dropping anymore. So maybe it's not able to progress further than a 90k loss of this model, right? And the Q is actually still increasing. Okay. Yeah, we're gonna stop it here and do the reward clipping and reward and loss clipping, which is I think the last thing I want to do for this stream. I think with the clipping we should be getting much lower loss. So this loss is still way too big. So I'm gonna clip it so that we limit the amount of reward or loss that we're getting and using for training, so that it doesn't skew the result towards the extreme. So here is what I'm gonna do. I'm gonna try to find the delta reward and just gonna clip the delta reward in a very simple way, I think. So I'm just gonna add a reward clipping logic here, right? Okay, so GitHub Copilot already knows what reward clipping is, so let's see what GitHub Copilot tells us to do. If reward clipping is greater than 1, then else if... I mean, technically that's a valid way to clip it, but I feel it's a little bit too extreme in our case. Because our reward is on the scale of like hundreds and thousands, right? So if you clip it to 1 and -1, if you clip it to 1 and -1, it might not be able to learn the nuances between a very good reward and an average reward. I mean, it could work. This could literally work, right? I mean, I haven't tried it. It could work, but just saying this might not be the best way to clip it. Let's just put it that way. I think I'm gonna put it at 10. I think that's a slightly better way to clip it. Because you can see the delta here is like hundreds, right? I think if we clip at 10, we can limit the loss and reward better. Of course, this is subject to tuning and hyperparameter tuning. So who knows what's the best? Maybe 1 and -1 is the better way. Maybe leave a comment what you think is the better way to clip this. Actually, I have no idea what's the better way to clip this. Yeah, so I'm just gonna use 10 and -10. Let's run a new set of training and see what happens. So this is hopefully the last run for this stream if it works well. If it doesn't work well, I'm just gonna try to fix it. I think this should theoretically yield a decent baseline, at least a very good, very decent baseline that we can improve and tune upon. So we haven't added so a few things are missing here, right? So we haven't added the convolution layer, which is very important. We haven't added the attack strategy, attack versus defense strategy yet, right? So this we haven't added. I think those are the two important features that I'm missing from this. Also, we need to take multiple actions and try them in series, right? Just like what we did previously. Series. Right, so like it could return like the best action is mine, the second best action is build. Then we will actually return the strategy that is an array. So for example, we could have stuff like build, mine, and build shipyard, right? And then we're just gonna take the top 3 action and then execute the strategies according to this priority, so that it's actually more powerful in a way. Of course, another thing we need to do is to add more layers and neurons, stuff like that. Right? And we could even add GPU. Of course, I think the first thing we should try is to submit to Kaggle and see how it works. Check if it works. So I think we're missing some dependencies for sure. So I'm not sure if the Kaggle guys are able to help us. I think they were willing to help because we're kind of trying new things here, and I think if we try to we implement the support for TFJS correctly, it's gonna open up doors for other people to try this. So I think they will be willing to accept. But now let's look at this loss. It's going up, which is not very good. The loss is going up, and the Q is flatlining. Maybe we have clipped the delta too much. I don't know. It could be just we're not training enough. But at least the loss is much lower, right? So that's a good thing. At least the loss is much lower. Or we could clip the loss higher than the reward so that it favors the reward more. Okay, the loss is actually going up. There are many reasons why this could happen, right? We didn't have convolution layer. We probably don't have enough layers and neurons anyway. Yeah, so there are many reasons why this is not working. Okay, the loss is starting to drop. We haven't even filled up our replay memory yet. So this is quite slow actually. This is quite slow. This is actually very slow. I feel like we should train more aggressively, like After each episode, we should probably train like 5 or 10 times instead of just once, so that it's much faster. We also need to tune the gamma to be higher. Yeah, see, it's losing every single game right now, which is okay because I wanted to like explore, right, at this stage of training. So at the beginning, it should explore all the options and then gradually became better. So it's okay that it's losing a lot of games right now. It's fine. It's to be expected. Actually, it's encouraged that it loses a lot of games, so that it explores all the action spaces. Alternatively, we could define our strategies more clearly, so it can divide strategies into smaller ones. For example, we can have a mine small, mine medium, build small, build medium, stuff like this, right? So we could divide it to a smaller one so that it has a more action space to choose from instead of, if it tries to mine, then it doesn't actually know whether we send out a small one or medium one because now currently the strategy dictates. So you have to make this more naive, right? Make strategies more naive, right? So this is what I mean by more naive. So we need to make it such that the model decides what to do instead of the logic decides what to do. Okay, so the Q is actually increasing pretty well from 130 to 163. Loss is 26 to 21. So it's actually doing way better than I expected it to be. And then you can see it's already started winning games. It's starting to win games, which is pretty nice. Even though we have a random chance of, this is the random chance. So the random chance of action epsilon is still at 40%. So it's not expected to win a lot of games anyway. Right. All right. Let's just keep watching this. I feel like this have the potential chance to be our first submission to Kaggle. Just a simple agent. We're gonna train it, I think, 100 episodes, and we're gonna try to watch some gameplay of it playing other AI, and then let's see if we can make it accepted by Kaggle. Because I feel like that's the hard part, right? To get some agent accepted. Because you need some kind of C dependencies or whatever, browser dependency, stuff like that, which is quite hard to do. So we managed to do quite a bit of work to get it run on the Kaggle environment. Hopefully the guy is gonna be able to help us. I might need to message him to get some help later. Okay, someone made a comment. After thinking about this for a while, I think a good solution would be add shipyard to include fleet collection method. Yes, I think it's correct, right? The fleet would. So turn order is collect allied fleets, add fleets to allied shipyard, collision battle with fleets and shipyards, adjacent battle between fleets. Okay. The only issue with this is fleet 2 strength attack with less than the ship survives with 100 ships. Enemy ship, fortunate. Okay. Yeah, this is a very interesting discussion taking place. I mean, it's a pretty interesting thing to think about. I'll post it in the chat in case anyone is interested in. Oh, no, I need to sign in. Let's just go to the studio and post it there, I guess. Content live. Okay, let's go into here and let's go to the YouTube link. Okay, let's say something here. Okay, so I posted the link to this discussion. Yeah. All right. Okay, let's avoid the infinite string thingy. Let's check out our agent. Q is starting to drop, which is not a very good sign. And the loss is dropping as well. Okay. It's still losing most of the game, so it's not performing better than the simple bot. I think we definitely need a convolution layer. What's the model architecture here? Wait, okay, I didn't log the model architecture, but it's not ideal. Let's just put it that way. Oh, but our random probability epsilon is still very high, so it's expected to lose actually. I wonder what will happen if the epsilon is lower. Okay, so I think one thing we could do is to train more in each episode, right? So we could, for example, train 5 times. So that would be 400 divided by 5 equals to 80. So we're gonna train for 80 iterations, which is fine. Or I think a good stat I think is 20. So that means we need to train 4 times 5, 20 times. That means we will train 20 iterations. Okay. Something like that. Okay, so this is not going too well. The loss is still increasing. I feel like gamma is definitely wrong. We should definitely change gamma to higher so it values the later stage, right? So if we take a look at this one, gamma 0.9 is 90 steps, right? So we need to tune gamma for sure. So if gamma is 99, then the reward in 60 steps. Right? So we probably need to change gamma to 0.99. Okay, maybe we should also add penalty for actions that didn't take place, but it's kind of hard to track that. It's quite hard to track whether the action has taken place. Yeah, it's quite hard. Okay, let me take a look at what simplebot does. Actually, I've never taken a look at the simplebot yet. Let's take a look at simple agent. So it spawns shipyard and launch ship, spawn and launch small fleet. Okay, so it's pretty decent baseline, actually, I would say. All right, looks like we're winning some games already. It looks like we're winning some games here. So that means this is actually working, right? Oh, but then we're also losing, and then immediately our loss shoot up, right? So that's a good thing. It's trying to learn that, you cannot have no ships at turn 313, otherwise you get eliminated, right? So you could also tune the removal function to add the ship count, but it's gonna screw up the gamma parameter internally. So it's not actually, I don't think it's a good idea to change the removal function. We'll just leave it as it is and let the gamma do the tuning of the time event horizon. Hmm. Okay, we're quite close to 100 episode already. So let's just wait a little bit more until we get 100 episode, then we can actually play the agent and see how it's actually performing the actions. And you can see now it's choosing a lot of action 3 to build shipyards, which is not actually which is not a good strategy, right? So it's still, I think, in the exploration stage where it's trying different strategies. As you can see, as it tries the to action 3, which is build shipyard, the loss is actually starting to increase, right? So it should correct this behavior and not build shipyards. So that's how it should work in theory. Uh, Maybe clipping 10 is too small. It's not able to learn that some of the reward is actually quite bad. Maybe 50 is better, I don't know. It's hard to say with this kind of hyperparameters which one is better. Now our Q is also dropping. It just keeps picking action tree. I guess in some cases action tree use the highest reward, right? That's why it's trying to pick action tree. Hmm. Actually, our loss has been increasing ever since, and our Q has been decreasing. Okay, now the loss start to drop. I feel like the model is too the board is too complicated for this model. That's the feeling that I have. It's not able to learn all the different mechanics yet. So now you can see it's picking less tree, right? It's learned that tree is not actually very good in some situations, so it's avoiding to pick tree, which is good. Okay, last 10 iterations. So how many times did we actually train the model? We only trained it 100. We only trained it 100 times 64 board states, right? That's only 64,000, 6,400. That's very little actually. We didn't train that much. So actually I would say that's not enough to get a decent model yet, but it's a good trial and learning experience for us to see whether this actually works. I think the conclusion is that it sort of works. Not, I wouldn't say this is a stable baseline yet. This is some, promising result, but it's not a stable baseline yet. So definitely we need to do a lot more to get a stable baseline. Like convolution, tune gamma, and bring in more episodes. So this will allow us to get a decent baseline. Okay, at least now the loss is less than 30k, which is something, I guess. I think this is the current model. Oh, I just realized something. We might not have been. We have not been actually using. Oh, it does. It does use the epsilon. Okay, sorry. I thought that we were not using epsilon, but it is actually using epsilon. Um. Okay. Okay. So that's the stats that we got. Not too sure what we can make of this yet. Uh. Yeah. Anyway. Uh. Let's remove the epsilon and see how it works. Let's remove the epsilon and we'll run a game. Okay, not against the powerful people, but against some simple AI. Watch for simple seems reasonable. So let's watch it play against 3 simple AI. So we disabled the epsilon, so now it should just execute whatever it feels like it. Right. So let's remove this in case we forget. Okay, let's see what it's trying to do. It's not doing anything and it's launching. It keeps trying to launch, but it doesn't realize it couldn't launch. Oh no, it's deterministic. That means it's just gonna keep trying to launch. Oh no, that is actually bad. That is bad. Okay, I guess I shouldn't have turned off the. I guess I shouldn't have added the epsilon really. It's still kind of necessary at this stage because it's not very good at doing what it does. Yeah, it's not, as you can see, it's not a good baseline. I wouldn't call it a baseline yet. It's not very good, right? So now it's just sending out random stuff and trying to build shipyard. It's always trying to build shipyard. I feel like it's just. Okay, so now it has some core, it's trying to build shipyard again. Okay, it's sending some miners, which is good. And it's actually successful in building a shipyard, which is very good, actually. So actually we came close to actually winning if you look at here, right? I mean, we're not close to winning, but we're doing pretty okay at this stage. We have 3 shipyards and we have 140 ships. And this is almost a decent baseline, but it's just, still not good enough. I would say not good enough for a baseline yet. Okay, so what I'm gonna do is I'm gonna delete the old models and then I'm gonna add this model here. So this is almost a good baseline, right? Almost decent baseline. we got this. Nice. Yeah, so I think this is end of today's stream. Well, this stream, I might stream later today, to get a decent baseline. And, all right, that's all for this